So to everyone who just joined, this is going to be an interactive training session. So if you can open the link either from your email or from the chat box and open up the Jamboard, and then put a sticky note on the sheet just saying why dimensions are important. And I'll wait a minute and then we can review what everyone has added.
I just put a whole bunch of it. Okay, I will write one more, then I'm done. How to spell garbage?
Garbage?
Uh-huh.
G-A-R-B-A-G-E.
Okay, thank you. You helped me. How to spell distracting?
Distracting. What does spelling mean? Distracting. D-I-S-T-R-A-C-T-I-N-G. Distracting.
Okay, my goodness.
Let's spell it.
And the medal for the B context goes to Jessica.
Yes.
Spelling bee, yay.
Thank you.
Yay, I'm a dinosaur.
Okay, we got a lot added onto here. So, this class is gonna be just kind of trying to look at why dimensions are like, or understanding like dimension points and how to know where to place your dimension points in drawings. And like the first question I want to ask everyone is, why are dimensions important? Because I think if we understand why they're so important, it helps a lot with the thinking you need to go through when you're placing dimensions on your drawings. So we've got the dimension obviously is important from anonymous some animal. It helps to track back the daylight opening. It's an important record for checking. It's needed in the construction industry. It allows you to create a more accurate product, allows you to identify mistakes, gives the relationship between two objects or locations, and I think this is a really, really important point that I'm gonna try and emphasize in our lesson today. Tells you about the size of an object, so I know what sizes to order stuff. And so a building closes, gives the other team correct information, and it's the main difference between a pretty picture and engineering drawings. We need to know who wants all the dimensions, what is the purpose of this dimensions you put in. It's a good point. And we need to know what the dimensions are not actually, we need to know that the dimensions are not actually the data in the Revit model as a visual element. And then you only put the dimensions which are useful for someone who needs it, which is true, but how do you really know what dimensions are useful? And extra dimension is a garbage who may distract the viewers. So I think these are good points for why dimensions are important. And let me know if anybody had problems adding post-it notes so we can fix them before we move on. Nope, okay. So I went through our shop drawing standards and looked at for all the references to DP or dimension or datum that we had in our standards to see, okay, so what do our standards say about dimension points? And if all you ever read were our standards, would you really know, how to add dimension points to your drawings? And So we really, you know, we have some.
Sorry, real quick, Jess.
Yeah.
Since everyone's looking at their Jamboard, I don't think they can see when you're flipping slides. So maybe we just let people know when you flip to the next slide.
Oh, okay. Please flip to the second slide. So we have some really like specific kind of notes about where we need to add dimensions in our standards. But where our standards are kind of missing is explaining how all these dimensions relate to each other and what their importance is. So that's what I'm going to try and review in this lesson with a couple of case studies. So for the interactive portion, if you guys will all just add a sticky note of what do you think the most important place to add dimensions is from our standards. And if you need to zoom in to see anything, there's a little magnifying glass on Jamboard that you can use.
It's good to know actually Jessica already put the slots in the Jamboard. You can flip the Jamboard to look at that one instead of watch the screen.
Yeah, so you guys can just go through the slides on Jamboard along with what I'm saying, or if you want, you can put Jamboard on one screen and zoom on the other screen.
Well, dimension strength should go to 1 point. What I mean? Of course, 1 point. I mean, dimension point, right?
Okay, so I'm getting a little bit of feedback. People are thinking the most important standards are dimension strings should go to 1 point, and to indicate DP on dimension strings is needed. Show overall building dimensions. So show the overall opening dimensions from these points to grid lines. So what I'm picking up on is mostly people are marking up the overall dimensions or the overall dimensions to grid lines, or making sure that the dimensions are coming from one consistent point as some of the most important dimensions. Does anyone have any last things they want to add to this before I flip to the next slide? Okay, we should have anchor point dimensions.
Well, should I adding this one over here? I don't see that happened. The reason I told you why.
Yeah, we can, I mean, we can talk about that stuff maybe at the end.
Okay.
For now, we'll just look at the standards that we have. So make sure dimensions on elevations tie to dimension points on details. That's a good point that I'm going to talk about later. Okay, so I'm gonna flip to slide 3 now. So first, I'm going to talk about project grid lines. So I've got the satellite view of 700 Santana Row before the building was ever constructed. And as you can see, it was just a parking lot. So when they decided to plan this building and they showed up the first day to build it, how did anybody know where anything was going to go? Like, they certainly weren't measuring from the parking lot stripes. It's because in planning stage, you know, the architect working with the surveyor and the GC laid out some project grid lines that they used in all their planning documents to describe where the building was going to go. And then everyone from that point on, when they're figuring out where their stuff's going to go and how they know how to size everything and put it, they're going to be working off those project grid lines. So here is just the site plan from that project, and on the site plan, they're only showing a few of the grid lines describing the perimeter of the site, and that was all they needed at first to lay things out, and then the rest of the grid lines kind of filled in the building according to the architect's design. So you can think of grid lines and then level floor lines as a way to define a 3D object in 2D space. So here I made these little 3D images where I've got the grid lines represented as planes and the floor lines as these green planes cutting through the building. And so every elevation or column or panel, it's going to hopefully be intersected by or close enough to one of these planes that in our 2D drawings we can get a measure, like a dimension there to kind of tell us where to locate that element. So here is one elevation on the bottom, one elevation that I isolated. And so you can see there's grid line A, that's the red plane, and then there's grid lines 11, 10, 9, 8, 7.8, 7, and 6 represented as gray planes, and then all the floor lines as green planes. So then I have a question for you guys to add with some sticky notes. So if you think of views referring to this elevation as the plan's elevations, sections, vertical details, horizontal details, what view would show grid line A? And you can just add a sticky note next to that question for what views would show grid line A. So we've got sections, plans, elevations, and floor views. Any views that intersect with grid A. Yes. So now if we're thinking about not the side elevation and that little snippet at the bottom, but just the main elevation that you can see the whole thing of, what view describing that main elevation would show grid line A? Because actually you wouldn't see grid line A in the elevation of that. Although, because grid line A is behind it and it's parallel to it. So grid line A would show up in the sections in the plans, and that would be dimensioned there in its relationship to the elevation. But it wouldn't, and it would show up in the elevation of the return windows. But it's still really important to describe in space where that main elevation is. So then what view would show level 2 and level 3? You guys can add sticky notes for that. So I got one that says floor plan and elevation shows level 2, 3. But does the floor plan show the plane of level 2? Because the floor plan is just looking down on the level, right? So where you see the plane and how it interacts with our elevation or our window, that's going to be in your section or in your elevation. You're not seeing how it interacts when you're looking at the floor plan. Okay. Then what view would show grid line 11, which is one of the gray planes? Okay, we have plan and elevation. Elevation perpendicular to grid line 11. Yeah, so basically grid line 11, you're going to see that in its relationship to this main window wall in your elevation. You're going to see it in your plan. And then you wouldn't see it in the section, but you would see it in the section of the adjacent elevation when you turn the corner. Or you can just think of it as any elevation perpendicular to grid line 11 or any view perpendicular to grid line 11. Okay, so if anybody has any comments on this last slide, let me know right now. All right, I'm going to go now to slide 5. Okay, so on slide 5, I've got an example of an elevation 17 where it is on the floor plan and then the section that goes through that elevation. And so the point I want to make here is that any dimension shown in any one view describing this window needs to match the related dimension in every other view. So you can see in the elevation, which I think everyone is pretty aware of. So you see in the elevation, it says we have 28 feet, 9 inches from DP to DP, and then 1 foot 3 to grid line D, 1 foot to grid line E.1, and those dimensions are showing up the same in the floor plan. And if they weren't showing up same in the floor plan, then we would have a problem that we would need to resolve. However, you're not going to find those dimensions in the section because the section view isn't cutting those planes. But on the elevation, you've got 9 foot 2.5 DP to DP for the height of this window. And that is going to show up also in the section, 9 foot 2.5 DP to DP. But you wouldn't see that dimension in the floor plan because the floor plan is not cutting through the right plane. Another relationship that you have described that's very important is you have the dimensions from the floor lines and then the dimension from the height of the window to the floor line, which is consistent in both the elevation and the section. And if they weren't matching, again, we would have a problem. Thank you to the narwhal. So how does this relate to details? Which pretty much, I think it's pretty easy for people to put 2 and 2 together and make sure that their plans, elevations, sections are all matching and that the dimensions are being pulled to consistent points. But where I see us making mistakes in drafting a lot of times is when we move to details. So the location of the dim point in details is very important because it needs to match the dimensions shown on the other views. So you can't just like pull a detail from the standard library and just assume that the DP in that detail is going to match whatever you're showing in your project. Or you can't just, dimension whatever you feel like on the elevations without checking back against your detail and making sure that you're pulling from a consistent point. So the reason you need to be consistent is because, again, we're trying to relate, explain relationships of a 3D object in a 2D format. So we need to make sure that any dimension point that we have can tie back to the elevations and then tie back to those grid lines so we know where everything's located. So here is here's a detail that I just made big on Jamboard, and I've highlighted the dim points. Now I'm gonna make it small again. So next to that is a graphic where it's just a zoomed in view of the elevation. And I highlighted the line that would be showing that DP to DP line. Now, if we had on our elevation, the detail that I just enlarged, the detail I just enlarged was call out, but we had the DP to DP line pulled to the inside of the cock joint, like shown in this flow up of the elevation, that would be a really big issue. Because our sizing of everything would then end up getting being off by 1/4 of an inch. However, then to the right, you can see a detail where the dimension point is being pulled from inside the cock joint. So what do you guys think if we had that detail instead of the first detail I showed you? Would that be okay? Would everything be able to be sized correctly and take off? You can put sticky notes. No. But why wouldn't it be able to be sized correctly if we had the blow up elevation?
I hope takeoff can give more feedback over here. That
Well,
makes sense.
so if we had our dimension point like shown in the blow up elevation with the dimension being pulled from the inside of the cock joint, and our detail was showing the dim point from the inside of the cock joint, actually there's no reason why takeoff would be wrong, because those are consistent. However, that's not how we normally do things, so everyone would be confused like they are now. So there's no reason to draw your detail like that last detail example. You're going to want your detail to look like the first detail example, but then you have to make sure your elevation does not look like that blow up elevation. So the line on this blow up elevation is not the jam, it's the cock joint.
I guess I was getting a little confused at what that object was here.
Yeah, that's the cock joint.
I thought this was the cock joint right there.
No, that's the little little cock joint.
So really, this is the left edge of the cock joint, correct?
Yeah.
Gotcha.
Can you guys hear me?
Yeah, you tricked us in it, Jessica.
What?
You tricked us in it.
I did trick you. I intentionally tricked you. Because the point I'm trying to make is, if you sometimes you end up with funny situations where you have to dimension in a non-standard way. Ideally, you would never have a detail dimension this way because it tricks everyone. So but maybe you do for whatever reason. You have to make sure you keep things consistent. And that's the very, very most important rule.
So I want to ask
the important rule is try and keep things how we always do it, so it's easier.
So again, so does the dimension is the data? I don't think my point of view maybe is wrong. I don't think dimension is really, it's a visual element. It's not actually data. The data actually is the model self. So
yeah.
Wrong does not mean the model is wrong. So the takeoff still get the correct data. Is that right?
I mean, maybe, because, we are also, this is just looking at dimensions. Whether or not the model is correct is kind of a different question entirely.
And it causes the checkers to kind of pause and then ask the question.
Yeah.
So, I mean, we really like to get it correct so that way, they can just confirm what they're checking and then just move on rather than having to stop and go back.
So I would have Yana to give us feedback. When you take off this one, when you, Yana, can you unmute yourself? I want to know you, when you do the takeoff, are you just pull the data in Excel file or you gonna compare with the dimension on the PDF file?
Me?
Are you compare that one? If you raise the question, is that because of conflict information? So you're gonna raise the question because the dimension.
I supposed to question it and compare it, but
Okay.
if you're asking specifically me, sometimes it goes past me and it gets cut and checking. Let's be honest.
I know. I think that's just related to James' question. It's in theory, but I know they have millions, hundreds data you have to compare. You don't have to. That's what we usually call logical checking, spot checking. You
Checkers everywhere.
Yeah.
And checker doesn't have any other job besides to check it. This compare with the details. So checker does it. This is why you see I have a luxury of having somebody else do it for me.
Yeah.
So the
But
checkers are always going to find this stuff.
So this is what I'm saying. The people who actually model, it's important. That's actually data. The people help the modeler put on the sheets. That's a secondary. That's a for presenter for the someone architect or shop or field or whatever something.
So if
are you trying to say the model is more important than what you dimension? I agree, but it's equally important, I think.
I know.
Model comes first, model it correct, but if you don't put dimensions correct, it's like.
I know. It's really depends from which point of view. For you guys, for fabrication accurate, model is definitely correct. For internally, it's important. But for externally, when you submit, the dimension is equally important because that will affect the architect will approve or not.
Then we're not gonna follow model even if it's correct and even if it's building is closing, if it's not matching dimensions. We will follow dimensions. Dimensions what's shown in details, what's shown will always prevail from what is modeled. Our assumption is follow the details, always.
Okay, yeah, that's a good conversation. But I also am going to later, Lynn, show you a critical error in the modeling that could happen from not understanding the dimensions. So we'll get to that later in the presentation. Cool. So I'm gonna flip the slide now. I think we're on slide 6. So this is a case study. That's what I called it. So I have here a image of a Inviso inside corner, and I've highlighted the dimension point I want you guys to look at. So imagine that we have an elevation looking at that corner. Well, I just realized I kind of showed you guys the mirrored. I should have highlighted the bottom dim point. So look at the bottom dim point. That's the same exact one. Thank you, Narwhal. Or I can circle it. So I just circled it on Jamboard. And kind of carefully study where that dim point is pulling from. Then in these little blow up elevations to the right, this time I have the caulk joint shown in yellow, so hopefully that will help avoid any confusion. So the caulk joints are shown in yellow. Which one of these elevations is pulling the DP to DP from the correct spot according to where that dim point is shown on the detail? Because I think whoever has the disappearing marker, there's a marker that doesn't disappear. Okay, so we're a little bit split, but it seems like most people are picking elevation 2. And actually elevation 2 is correct, which seems counterintuitive because, as we just discussed earlier, in most cases, we're dimensioning from the outside of the caulk joint, and when we dimension from the inside, everyone gets confused. Well, for this, and this is our standard inside corner detail. If you study it carefully, which let me make it bigger, you'll see that if you trace where the DP is going, the dim point is going to, it's actually ending on the inside of the caulk joint because it's aligning with the face of system of the return elevation. And if you were to try and put your DP to, the outside of the caulk joint, then you would have a very, very confusing looking detail, and it would be really easy to dimension it incorrectly on the floor plans because you would have overlapping dimension strings. So the point of this exercise was really just to show, like, we can have some kind of standard logic that we try and follow all the time, but you really need to be studying and comparing, studying your details really closely to make sure that, those rules work in every case, because they don't work in every case. And it's really important to get that stuff, those dimensions pulling from the right location. And related to, Len's point that, well, we need to make sure the data is correct. Well, if you're a drafter and you're modeling a wall like this, and you just make your wall and you add your 1/2 inch caulk joints to your wall, and you decide to snap the endpoints of your wall together, your model is going to be incorrect. But if you're paying really close attention to those DPs in this detail, you might realize, oh, actually, either, if you want the caulk joints in your model, you've got to kind of make sure your walls don't snap together at the corner and overlap them by that 1/2 inch, or you just don't even include the caulk joint in your model to make sure everything ends up in the right location. Why don't we use the target to indicate the matched dimension point?
Yeah, that's what we usually use.
It's just not in our standards. I don't know. We can talk about this at the end in terms of changing stuff, but right now we're just trying to explain the dimension points
Okay.
with what we typically do. So
I'll cover my notes.
Mhm.
Somebody get
Oh.
away from it.
the narwhal is saying sometimes we do. Okay, so I'm gonna flip to the next frame, frame 7. So here, I've got the highlighted dim point, and this is showing a Invisojam inside corner and a capture jam inside corner. So it's a little bit more complicated and not a typical detail. So here I have the same question. Which of those elevations shown is showing the DP to DP to the correct spot for that highlighted dim? Yeah, so it looks like everyone is seeing that, it's different than the previous case study. So actually, in this case, the DP to DP would be pulling from the outside of the caulk joint. And that's what the detail is showing. Because, I mean, and the reason why is because you don't want the face cover to be colliding with the Invisojam. So now I have, oh, sorry, I'm switching pages, page 8. Now I have another case study of this condition where a snap joint transitions into a sill. And so I just took a little snip of the elevation, and I highlighted the detail that I have examples of below. So looking at this elevation, which detail is showing the correct dim point? And I'm gonna just temporarily make them bigger so it's easier to see. Okay, so on the left we have detail 1, and on the right we have detail 2. And I'll leave them big for a second, and then I'm going to shrink them down again.
Which page you on? 6, 7, 8.
Are you guys ready for the answer? Or are people still thinking about it? All right, so I'll just go because we've definitely split the room again. So I see a lot of people choosing detail 2, and it kind of makes sense because that's typically what a sill detail would look like. You are gonna dimension from the caulk joint, but actually in this case, because we've got this transition from a stack joint to a sill detail, and you're using all the same parts. Actually, the detail that was created and called out in the elevations was detail number 1, because detail number 1 is using this 5.5 inch from floor line dimension point and just still pulling from it right here where it's calling out the dimension point. And if you were to use detail 2, I mean, potentially you could do that, but that would mean that you have to make sure that you've got another DP on the right side of your drawing that's pulling from that detail 2 dimension point location, which might work or might not work depending on the shape of your elevation, and it might actually end up causing some confusion since you're switching dimension points. So this was also a tricky question, but it's important to, the importance of this is not to just kind of assume. Someone said we have to provide 2 details here, but why would you have to provide 2 details? Can the anonymous?
Yeah, because I think here we have it's confusing because we have stacked on this area. We can provide 2 detail. It's clear for everybody. They know DP is exactly this location.
So I think that's just that dimension was cut off in my snip. Yes. Good point. You want to see that 5.5 inch dimension. But I guess I should have circled the 4'10", is what that's the dimension line that's going to the top of the stack joint that you're carrying over. So someone said missing the unit module dimension. That's not in our standards.
Okay, that's not the answer. That's not the answer to me. I'm just pointing out we're missing that.
It's just that's just not the way that we dimension our drawings.
Okay, understandable.
But with the way we dimension them, it's important to keep the relationships, tracking from the detail to the elevation. That's what's important. So if your dimension strings on the elevation are just going to the top of the stack joint, then your dimension point and the detail needs to go to the top of the stack joint. And the only way you can have your dimension point and the detail coming from the bottom of the caulk joint is if you've got that dimension string on the elevation. So now I'm going to switch to page 9, slide 9. So here is an example of what can happen when you get a standard detail or a profile detail, and then you kind of make an assumption about where your model elements need to go just based on looking at that detail, but not really looking into things more. So the stack joint detail on the top left is just a stack joint detail showing that from the profile drawings, showing that the stack joint is 5.5 inches above the floor slab. And so then if you look on the right, that little section, you can see, you know, how maybe the drafter would just go in and model the, just say, okay, well, top of floor slab, that must be my floor line. So here, I'm just going to model my stack joint at 5.5 inches above the floor line. But then imagine, if you will, we've got some condition like what I just enlarged on the Jamboard. This is a snip from a structural plan showing a depression of 1.5 inches below the floor line. So actually what's going on, which is not reflected in the profile detail, is that the slab is actually 1.5 inches below the floor line. So what does that mean for where your stack joint needs to go and what your detail needs to look like? So I'm going to enlarge 2 options. You could have something that looks like this. If you add in the floor line and you show that 1.5 inch depression, now your stack joint is 7 inches above the slab, but you're keeping that 5.5 inch dimension above the floor line. Or you could have something like this that I'm going to enlarge, where your slab drops 1.5 inches below the floor line, but you don't expand or you don't increase the distance from the slab to the top of your stack joint. You keep it 5.5 inches, which actually means your dimension from floor line to top of stack joint is going to shrink to 4 inches. So if that was the detail, that is the correct detail to use, you can't just, you know, change that up in your details. You would also have to go back to your section and change the section. So I just enlarged the revised section, and then I'm going to bring the old section to the front. So here you can see a critical error that could happen in sizing our units if something like this was missed just because someone looked at their profile details or whatever and made an assumption about where the floor line is based on that when they were modeling. So that's why, you know, it's really important to understand where your dimension points are going to and how it's all working together with the elevations, with the sections when you're making your details and modeling. So now I'm going to go to page 10, and this is another exercise, which is a little bit different than what we were talking about before. So I showed an example of a floor plan with, let's say you get this imaginary markup from an architect, and people just leave sticky notes on what they would do if they just got this markup. Yeah, so everyone is pretty clear that these instructions from this imaginary architect are not good enough to actually make the change. So you can bang your head against the wall or send an RFI asking for clarification, because, you know, if you're being told, oh, just adjust this dimension, well, where are you adjusting it from? You know, everything's in a relationship to each other. So it's not enough to just, you know, change a number somewhere. It's always describing some relationship. So you need to know you need to know what the changes are and how they affect those relationships. Yeah, so you would need clarification. Okay, so then for the last slide, I just kind of have an open forum, and we can talk, Lynn, about your ideas for improvement, or if people could place some sticky notes, just kind of discussing some, conditions that they frequently see the wrong dimensions placed either on elevations or details or plans. Match line DP, that's a really good one. Should we not model a cock joint at inside corner? I mean, that's a good question because it probably depends if it's an inviso inside corner or a captured inside corner, but even then you might have some job specific conditions. Corners, any corners, yes, corners are very easy to get wrong. Drop soffits that conceal part of the window head. Yeah, that's definitely easy to get wrong because you might be hiding the cock joint but still showing your dimension coming from there in the detail. Imaginary dim points. Yeah, and I would also add to that, I guess, when we have a all inviso in a system and an all captured system, sometimes we can get those dim points confused. Inside corner. Segmented elevations and details, which we didn't even touch on in this training, are a whole different challenge. So someone said, I think it's hard to get the correct dimension on the elevation and then the plan. I don't know if you're up to it, whoever posted that, could you explain what you meant? Oh, if it's you, Lynn, you're muted.
Oh, I mean, that's me. The reason I say this one is I understand we have like over 40 years experience. We always dimension everything on the elevation because we tag this way. That's the way we are doing. But the things I see this one, you can see it's very hard to get the correct dimension point on elevation compared with on the plan view. So my experience is you have elevation, then you have a reflect plan view underneath of it. You can put module dimension over there, dimension point. So the elevation show the tags, each unit, whatever you use over there. But the dimension should on the plan view, it's much easier. I guarantee you will get less wrong point over there. That's my, have one elevation of the unit that have two plan cuts. One's cut at the regular vision point, one's cut at the spandrel, which is show direction where the anchor point is.
Yeah,
So
I think that's happened on a few jobs.
Yeah, I think I showed the example last year to someone what we usually do, the shop drawings. So 3 drawings, 3 views to show 1 elevation. 1 elevation, 2 plan sections. One's vision, one's at the anchor. That's our standard. I mean, previously.
Okay. It's a good point. And I mean, maybe there is some room to look at how we're dimensioning things to try and make it easier to get these relationships correct. Door threshold dimension. I think that's easy to mess up. Corners, angled walls, and rivet. Yeah, I don't even know how we dimension angled walls on the floor plans in Revit, since it will be so hard to get a cut where you can get the right point. Sloped walls. Cool. Does anybody have any feedback before the lesson ends?
Great job, Jess.
Thanks.
Thank you, Jess. Very good. I'm impressed about the Jamboard.
Well, yeah, thank you everyone for participating, because otherwise this would have been awkward.
Yeah, I think it was a great idea to do it like this because kind of keeps you engaged.
Right, it's
feel like
interaction. It's much efficient this way. Yeah. Great.
Easier to retain the info.
Mhm.
Yeah, thank you, Jessica. Good idea.
Thank you, Jessica.
Thanks everyone, and if you ever want to look at the Jamboard again, it's not going anywhere, so. Thanks.
All right.
Thank you.
Thank you.
Bye,
You
guys.
guys have a good Thursday.
Will do. All right. Catch you later.